Hello everyone, welcome to all in this lecture. So in this lecture, I'm going to discuss get previous year questions that is based on the bearing capacity of soil topic. So in coming lecture, I will try to cover each and every get previous year questions from the soil mechanics. So before going to start the numericals, let's discuss what is the gate. So gate exam basically, gate is the graduate aptitude test in engineering, and this exam is happening in an online mode, computer-based test. The exam duration is 3 hours, 180 minutes. Total number of questions in the gate you will see 65. Total marks, 100 marks. And there are two types of questions. Multiple choice question, it can be for 1 marks or it can be for 2 marks. Numerical answer type question. So in this section, you have to fill the numerical value. Suppose you get some value like 5, like 6, like 7, whatever. And this question, all the 65 questions are asked in the different section. So the first section is general aptitude, that is for 15 marks. Engineering mathematics, that is for 15 marks. And for the subject, that is I'm talking about civil engineering. So civil engineering is for 70 marks. Civil engineering for 70 marks. There is a marking and scheme also. जो आपको बहुत ध्यान देना है उस पे. अगर जो मल्टीपल चॉइस क्वेश्चन है 1 मार्क्स का, so there is a if you have for the wrong answer you will get deducted by 1 by 3 marks. For 2 marks MCQ questions will get deducted by 2 by 3 marks if you have answered any wrong. There is a no negative marking for wrong answer in numerical answer type questions. So suppose the correct answer was 5 or you have written 8. So this answer is wrong, but you won't get any, and marks will not deducted. There is no negative marking, right? And there is a no marks will deducted for unattempted question. Suppose you have left some questions, so you won't get any marks. So your marks will not be deducted, right? So in this here I have mentioned geotechnical syllabus for the GATE examination. So generally, if you are studying in the BTech, you will see this portion is basically cover GTech 1, and this portion is basically related to the foundation, which is covering GTech 2, right? And this you have seen that total 70 marks came. सिविल इंजीनियरिंग से कितने क्वेश्चन पूछे जाते हैं? For 17 marks. और इस 17 marks में 50 to 16 marks for soil mechanics, from the soil mechanics. So you can see the geotechnical engineering subject is very, very important for the GATE. If you have decided, you have fixed the target that you want a good all India rank, AIR rank, so you cannot leave this portion. Cannot leave this portion. If you are leaving this portion, then it's very difficult to get a good all India rank. So you have to cover this geotechnical engineering subject in a proper way. So I'm here to help you. So I will try to cover, first I will try to cover each and every question from the geotechnical in subject that have asked in the GATE previous year question, GATE previous year examination. And once it will over, then I will try to cover other subject also, right? So let's start. So the first question we have, in the first question, the percent reduction in the bearing capacity for the strip footing is mentioned, strip footing resting on a sand under the flooding condition when the water level at the base of the footing when compared to the situation where the water level is at the depth of much greater than width of the footing, right? So here are two information are given in the question. One is foundation is resting on the sand. So first, resting means sand, means whatever the Resting means, suppose this is the sand, right? And for the foundation are resting here. So we'll see there is a no depth of foundation, means depth of foundation will be 0. So whenever in the question it is given, the footing are resting on a sand, footing are resting on a soil, on a clay. So in that case, you can take df is equal to 0 or df will be 0. Depth of foundation will be 0. There's other information also that sand. In the question it mentions sand. So for sand we know C is equal to 0. There is no cohesion property for a sand. So two important information we are getting. Okay. So now let's start. There are two conditions. So suppose this is the foundation we have. First case where the water level at the base of the footing, this is the water level at the base of the footing. And the second case where the, suppose the water level is a b distance from the base of the footing, and that is b is greater than capital B, that is width of footing. So you will see when the water table is gets reached to the base of the footing, so you will see there is a reduction in the bearing capacity swell, the reduction in the ultimate bearing capacity of swell. So in the question it is asking what is the percentage of reduction as compared to ultimate bearing capacity when the water table has a greater depth from the width of the footing. Now you got the questions. So let's start to solve this question. So let's calculate what is the bearing capacity. So write the formula for the strip footing. CNC plus gamma dF plus NQ, where plus half gamma BN gamma, right? So in the question it mentions sand, means C is equal to 0. So this expression will be 0. This expression also will be 0 because in footing is resting on the sand, means depth of foundation is 0. So this expression will be also 0. So third expression. So directly we can write ultimate bearing capacity is half Bn gamma, right? Half N gamma. Okay, so for the first case, we can calculate ultimate bearing capacity. So when the water table at the base of the footing, it means whatever the soil that is beneath the footing, just beneath the footing, that is in the submerged condition. So we can write half gamma submerged Bn gamma. Now we can calculate for the second condition, that will be half if the water table has a much greater than depth from the base of the footing, so that whatever the soil which is beneath the footing, that will be in the bulk condition. So bulk condition it is denoted by gamma also or gamma T also, right? You will see where in this case where the B is greater than B, right? This is the case where the B is greater than B, or B is greater than B. If B will be less than B or greater than 0, so this case we will see there is a water reduction factor that is called gamma W. So that I will discuss in the next coming questions. Okay, so that's why I'm not discussing here. So now we can go for the reduction, percentage reduction. So we can write half gamma Bn gamma minus half gamma submerged into Bn gamma, and percentage reduction we have to calculate half into gamma Bn gamma. So you can take the ratio, you can take common, दैट हाफ बी एन गामा, अगर ये आप कॉमन लेते हो तो क्या बचेगा आपको, गामा माइनस गामा सबमर्ज डिवाइड बाय गामा. So we get this one. So there is a little assumption that bulk density of soil is half of bulk density of soil is 2 times of the submerged density of a soil, right? So you can see, sir, this question answer is based on the assumption. No, this is a very common assumption. This is very common assumption. What is the assumption? That gamma submerged is half of bulk. You can see the expression when suppose we are not accepting this, suppose. So suppose in this case, see the option, right? If gamma submerged is 0, then this percentage will become 100. So gamma submerged is 0, then it will be 100% reduction. So gamma cannot be 0. Gamma dash or bulk density of submerged density of soil cannot be 0. So this option cannot be true. Similarly, if gamma submerged is equal to gamma, so we can get the percentage reduction, that is 0. So that is not true because gamma submerged is not equal to bulk, that we know. So here we have the two options. If you will see 25%, 50%. So there is a common assumption that we will see that gamma submerged unit weight of soil is more or less half of the unit weight of some soil in a submerged condition. So by using this relation, you can get gamma minus 0.5 gamma divided by gamma. You can get 0.5 into gamma into gamma. So get 0.5. So in percentage, you have to multiply with 100, so you can get 50%. In the question it is mentioned what is percentage reduction. So we have the 50%, so C option is correct. C option is correct. Let's go for the next question. So you can see in the question it mentioned width of the square footing and the diameter of the circular footing are equal, right? If both the footing are placed on the surface of sandy soil, right? The ratio of the ultimate bearing capacity of the circular footing to that of a square footing will be. So we have to calculate ultimate bearing capacity to circular to the ratio of ultimate bearing capacity to the square. So we have to calculate this one. So in the question it is mentioned footings placed on the surface of sandy soil. Surface it means TF is equal to 0, right? And sandy soil, for the sandy soil it means C is equal to 0. So we can use this relation. Okay. So now let's go to calculate ultimate bearing capacity of soil for circular and for square. Okay. So let's calculate ultimate bearing capacity for a square for circular. So we can write 1.3 CNC plus gamma TF and Q plus half gamma B and gamma, right? So you can see this case where the sand means C is equal to 0, so this will be 0. And resting on the footing means df is equal to 0, so this will be 0. So directly you can write, and this is not correct. This is 0.3. This is 0.3. So what we get ultimate bearing capacity for circular, we get 0.3 gamma B and gamma, right? Now we can calculate for square. So direct we can calculate the expression with the cohesion will be 0, and expression with the overburden pressure because df is equal to 0, so will be, and this is 0.4 comma bn gamma. So directly we can write 0.3 comma bn gamma divided by 0.4 comma bn gamma. So this will be cancelled. So by simplifying, it will come 3 by 4. So you can select the option that is C answer. So here the C option is correct. So this is the two very important information are given in the questions. First is sandy. Sandy means C is equal to 0. And second, the surface means df is equal to 0. So that you have to keep in mind. So let's go for the next question that we have. The question will mention a strip footing. A strip footing is resting on the surface. Resting on the surface means df is equal to 0 on purely cohesive soil. Purely cohesive soil means phi is equal to 0. If phi is equal to 0, so from the Terzaghi bearing capacity factors tables, you will see the tables, you will get that NC is equal to 5.7, NQ is equal to 1, N gamma is equal to 0. And that you have to remember. Because in the 1 mark question, you will see in the most of the gate question, they are saying it is mentioned phi is equal to 0, but they have not mentioned any data about this. So you have to be remember all these things. NC is equal to 5.7, NQ is equal to 1, N gamma is equal to 0, when phi is equal to 0 for cohesive soil, for purely cohesive soil, right? Okay. So now, if the tip width of the footing is double, the ultimate bearing capacity of the soil. So let's calculate, write the formula. What is the bearing capacity, ultimate bearing capacity of soil for strip footing? So formula we have CNC gamma dfn plus half b n gamma n gamma. See, footing is resting on the surface, so df is equal to 0, so this expression will be 0. Here phi is equal to 0, so n gamma is equal to 0, so this expression will be 0. So finally we get 5.7 after putting the value of NC, got this, right? So you can see ultimate bearing capacity, it depends only on the cohesion in this condition. So whatever you are changing, you are doing something in dimension of the footing, the ultimate bearing capacity will not affect, it will not change. So you can select the option remains the same. Option D is correct. Because in the expression, you can see ultimate bearing capacity depending upon the cohesion of the soil. Cohesion of the soil. In this case, are you getting a point? Okay. Now let's go for the next questions that we have. Question number 4. Net ultimate bearing capacity. See, mention net ultimate bearing capacity. Net ultimate bearing capacity means QNU. It is not QU. And QNU is equal to QU minus gamma DF. And this gamma DF is nothing but overburden pressure. Overburden pressure. See, in the question, net ultimate bearing capacity of a footing embedded in a clay stratum. Again, it mentioned clay. Clay means phi is equal to 0. If phi is equal to 0, there is NC 5.7, NQ 1, N gamma 0. So we can calculate the ultimate bearing capacity. We can calculate CNC plus gamma DFNQ plus half gamma BN gamma. So N gamma is equal to 0, after phi is equal to 0, so this expression will be 0. right? After we can put the value n is equal to 1, so we can write n c plus gamma df, right? So we can calculate net ultimate. So net ultimate bearing capacity is equal to gross ultimate or ultimate minus gamma df. So we can put the value of QU. So we can write CNC plus gamma df minus gamma df. So this will cancel. Finally, we got CNC is equal to QNU. So you can see in this expression, net ultimate bearing capacity of a soil depending only on C, because NC we have 5.7. So in this question, you can see it's independent of depth and size of the footing. You can see because it's only depending upon the cohesion. If in the option it is mentioned, it will be there. So, it will be changed by changing the cohesion. So we can select that option. But here you can see it is changing only in the dimension. So D option is correct. It is independent of depth and size of footing. Clear? Okay. So next question we have. So the question which I'm discussing here, that is 1 marks question. I mentioned in the right side, it is asked in the year of 2004. So in the question C, two circular footing diameter D1 and D2 are resting on the surface. Whenever you will see resting on the surface, just take TF equal to 0. On purely cohesive soil, again, other information of the purely cohesive soil means phi is equal to 0. Phi is equal to 0. अभी जैसे लिखते ये लिख लो कि NC is equal to 5.7, NQ is equal to 1, N gamma is equal to 0. So अब देखो कि half of the question is already solved. So now we have to calculate the ratio. So finally now let's go to calculate ultimate bearing capacity. First write the formula. So you can see CNC plus gamma df and q plus half gamma b n gamma. So by putting the n gamma is equal to 0, this will be 0. We can put 1, nq is equal to. So we can write, and this is resting on the surface, means df is equal to 0. So this expression will be also 0, right? So finally we will see we got the NQ, QU, CNC, right? Or simplify, we can write by simplifying 5.cc. So we can see ultimate bearing capacity is not depending upon the dimension of the circular footing. It is independent of their dimension. So in the both cases, QU will be same. So we can calculate QU for the D1, QU for the D2. So in the both the cases, you will see 5.7C, 5.7C. You get 1.0. You get the ratio 1. Now you can choose the option that is C. Sorry, that is B. So option B is correct. Option B is correct. So जब भी आप कोई problem solve कर रहे हो, so you have to be see what are the data given and what the data we have to calculate, and try to some relation to connect both the things, what are the data given and what we have to calculate, right? So this is the basic strategy to solve the question. So next question we have, you can see the width and the depth of the footing are given 2 meter and 1.5 meter. So you can see this is given. This is given B and this is given depth of foundation respectively. The water table at the side is 3 meters below the ground level. So this is showing in the question. You can understand by this figure. So this is given 2 meter and depth of foundation is given this is given 1.5 meter, right, and 3 meter below the ground level, and from this point to this point, this is the here the water table. This is the water table, and the dimension is depth is 3 meter from the ground level. Okay, so the water table correction factor for the calculation of bearing capacity of soil, right? So you will see. Let me write the formula with correction factor. So you will see there is a ultimate. You can write C and C plus gamma df nq wq plus half b gamma n gamma w n gamma w gamma. So here are you can see there is a w gamma and wq and w gamma. Here are two water correction factor. So for the second term, there is a correction factor, a water correction factor, WQ. For the third term, there is a water correction factor, W gamma. So you can write Q. So you can write Q WQ is equal to 1 minus 0.5 A divided by A, that A divided by DF. It should not be less than, it should not be greater than 1, so it should be less than equal to 1. And there is a correction factor W gamma, that is 0.5 plus 0.5 B divided by B. Right? It should be less than equal to 1. So you will see A. So whatever the water table, when water table at this level, so the depth of water table, the height of water table from the this base of the footing, so this distance is called A. This distance is called A. When the water table is below the base of the footing, so you have to neglect this value. This value will be 0. Or you can take this value will be 1. Sorry. So when the water level is below the base of the footing, you can see the value. If you will put the value in the negative of A, so this will be greater of 4. So this case 1. So when the water table is below the base of the footing, so WQ will be 1. Right? So in this case, you can see water table is below the base of the footing. So this WQ will be 1. And let's see the calculate other water correction factor. So let's go to calculate gamma W. So let's put the value of 0.5 plus 0.5. What is the B? So B is the water table, distance of water table between the distance of water table to the base of the footing. So this distance is B. Water level to the base of the footing. So this distance is called small b. So what is the small b here? So you can see from this height, this is a 1.5 meter, total height is 3 meter. So this will be, a small b will be 1.5 meter. And capital B we have width of the footing, that is 2. By watching this lecture, always keep some calculator notes and try to solve. I have solved this question, so I'm directly writing the value. But you also before this writing the answer, you just write by yourself. And if you are this is I'm solving the GATE previous year question, so better you use virtual calculator. So you will get some practice. So in the exam you will will be so friendly with the virtual calculator. So you can write by solving you will get the value of 0.875. So we can see in this question we get two water reduction factor Q is equal to 1 and WQ is equal to 1 and W gamma is equal to 0.875. See, so both reduction factor are given in the first option is this 0.87. So, and second option is 1. So, what is correct? Which option you will choose? So, see, water correction factor 1, it means there is a no correction. There is a no correction of water. So, whenever you are getting the 1, it means no correction. There is a no correction. No need to do correction. In the second case, you need some correction. You need some correction. So in this case, it is asking about water correction factor. So answer will be 0.875, means A option will be correct. Are you getting my point? WQ is equal to 1, it means there is no correction. And we are getting W gamma 0.875, it means there is a correction in the third term. Gamma WQ is the correction factor for the second term. There is a when there is a overburden pressure, there is a gamma DF, there is a gamma DF and Q. And W gamma is the correction factor for the third term, right? So always remember all these things. Let's have next question. So you can see in the question it is given, the following two statements are made with the reference to calculation of net bearing capacity of footing on purely cohesive soil phi is equal to 0 using the Terzaghi bearing capacity theory. So see, in the question it is mentioned phi is equal to 0, so it means NC 5.7, NQ1, N gamma is equal to 0, right? And it is asking about the QNA. So directly we can write QNE, that is QU minus gamma DF. So you can write CNC plus gamma DF NQ minus 1 plus half. What is the type of footing? They do not mention, so right for a strip footing, gamma BN gamma. So see, by putting the value of N gamma is equal to 0, so this expression will be nullified. And by putting the NQ is equal to 1, this expression will be 0, so this expression also becomes 0. So our net ultimate bearing capacity will be C into 5.7. Now you can see, check the option. So you can see net ultimate bearing capacity of soil only depending upon the cohesion C, right? So now check the option. Increase in the footing with the result in increase in the bearing capacity of soil. So this is not correct. This is false. Increase in the depth of foundation will result in higher bearing capacity. This is also not correct. Because with increasing or decreasing or dimension, it is independent of the dimension, so it will not change. So both statements are false. This option is correct. Option B is correct. Let's go for the second question. Next question. Question number 8. Say foundation is considered a shallow. A foundation is considered as a shallow. This is not a shallow. This is shallow foundation, right? This is shallow. Okay, so you can see. Okay, so by according to the Terzaghi, you can see the depth of foundation is equal to width of foundation. Then we call a shallow foundation. Shallow foundation. So you can see there is a C option correct. It is equal to or less than its width. It is very easy questions. So next question we have question number 9. Increasing the depth of foundation in saturated clay result in increase in the ultimate bearing capacity for the strip footing. So see, in the question it did mention clay. It means phi is equal to 0. Phi is equal to 0, it means NC is equal to 5.7, NQ is equal to 1, and gamma is equal to 0. And here talking about the ultimate bearing capacity. So let's calculate the ultimate bearing capacity QU C and C plus gamma DF and Q plus gamma B and gamma. So by putting the value of n gamma is equal to 0, this expression will be 0 and NQ is equal to 1. So we can write 5.7 C plus gamma DF. See, in the question it mentioned ultimate bearing capacity, right? So ultimate capacity is this. So now we can go to select the option because increase. So a statement is correct. Increase the depth of foundation, DF will increase. So ultimate bearing capacity will increase. So Q will increase when DF will increase. So a statement is right because the bearing capacity factor NQ is increasing. No, NQ is not changing. NQ is 1. So this option is not correct. Because the bearing capacity factor NC increasing. No, this is not bearing capacity factor or Terzaghi's capacity equation factor are those NC, NQ, and N gamma are not changing. The term in the bearing capacity NQ increasing with depth. This option is correct because this is the expression. We are talking about Q and Q. So in this expression, this is Q is increasing. So C option is correct. Let's check the D option also because the angle of internal friction is not correct. So here the option C is correct. Are you getting my point? Okay. So let's discuss the next question. For this is, I think, the last question for this lecture. Okay. So the ultimate bearing capacity of a surface strip footing on a clay. So see, surface strip footing. So for the surface means DF is equal to 0. Clay means phi is equal to 0 and C 5.7 and Q 1 and gamma H 0. According to the Terzaghi theory, so we can calculate ultimate bearing capacity QU. Directly we can write? No. From the next lecture, I will write directly. For this lecture, I am writing each and everything. Okay, so we had the n gamma is equal to 0, so this expression will be 0. We had the DF is equal to 0, so this expression will be 0. So we can write QU is equal to 5.7 C. Now you can choose the option. So option A is correct. The option is correct. So thank you. So you've seen the 10 questions that I've solved from the GATE previous year questions. In the next lecture also I will discuss the previous year question that is based on the bearing capacity of shell in the fourth lecture. In the fourth lecture, I will finish all this question in the fourth lecture and I will try to upload more and more video based on the numerical problem that is from the GATE previous year questions. So okay, thank you. By watching this lecture, always you do the calculation before. मुझे मेरे लिखने से पहले आंसर लिखने से पहले आपको कैलकुलेशन करके लिखना है. देखो ये जो लेक्चर है ये आपके कोर्स के अकॉर्डिंग नहीं है. दिस इज नॉट related to your syllabus, right? You can watch this lecture. There is no issue. But those who are preparing for GATE, those who are serious in the preparation of GATE, and those who want to get the more and more marks in the GATE examination, and those who want to get good all India rank in the GATE examination. So you have to practice each and every questions. You have to see the concept. You have to see the what are the question, what question are saying, what are the data given, and what we have to calculate. So, and what are the relation that will connect to both given and finding what we have to find. So we always have to be, and by doing this calculation, it is better. It is better if you use the virtual calculator, because in the GATE examination there is no calculator are there like offline calculator. So there is a virtual calculator. It will come on the screen. So do the practice for the virtual calculator, and I will upload more lecture. So thank you everyone.